Far out in a remote part of the Sahara Desert, there's a mystery. Scattered around in the sand are chunks of yellow-green glass. But this desert glass is a scientific enigma. How did it get here? How was it made?
It is really a mysterious glass, and we scientists are still kind of puzzled how these things formed.
The search for an answer has taken scientists from the depths of the desert to the Egyptian Museum in Cairo and the test site of the world's first atomic bomb. What they've revealed poses an unsuspected threat to us all.
What I want to emphasize is that it's hugely bigger in energy than the atomic test, 10,000 times more powerful.
A team of scientists is on a mission heading for the Great Sand Sea of the Egyptian Sahara Desert. Their aim? To visit the remote area where the desert glass is located and solve the mystery of how it came to be there. One of the scientists, American physicist Dr. Mark Boslow, thinks he may have the answer.
It's a scientific mystery because it's unique. We don't know exactly what the process was that caused the creation of the glass. We know it's a natural phenomenon, and therefore it requires a natural explanation. It may be a very unusual event, but it's certainly not a mystery that can't be solved.
Working with colleagues, Boslow has developed a dramatic new theory to explain how the mysterious glass was produced. He has a terrifying vision of what happened here. The details of Boslow's theory are still sketchy, but he hopes the evidence in the desert will give him a clearer picture. It's Boslow's first trip to the desert, but also in the team is geologist Ali Barakat. Barakat is Egypt's desert glass expert and has traveled to the area several times.
We must go to the south and go to the north. I know the area like my finger.
But they're
Barakat's interest dates back to 1998 and a remarkable discovery in which he was involved. It took place in the Egyptian Museum in Cairo. Italian scientist Vincenzo Di Michele had been looking at the gems and semi-precious stones used by the ancient Egyptians. Hidden away in a dark corner of the Tutankhamun exhibition, he found a piece which caught his eye. One of Tutankhamun's necklaces, made of different colored gems. It was the yellow-green carved scarab in the center that attracted his attention. It was said to be chalcedony, a semi-precious stone. But de Michele was not convinced and asked Barakat to help. Surrounded by armed guards and officials, they were allowed to examine and test the jewel. Using a refractometer, they measured the scarab's optical properties, the refractive index. And the tests revealed that the scarab was not a semi-precious stone. In fact, it was made of glass. But it was not a glass like any other produced by the ancient Egyptians. Barakat realized the scarab was identical to samples of natural glass which, in the past, explorers had brought back from the Great Sand Sea, a remote region of the Sahara. But the mystery was as deep as ever. What this glass is doing in the desert has never been explained. Since the discovery of Tutankhamun's jewel, several scientific teams have traveled into the desert looking for answers. Now the latest team is on the start of a journey to visit the area where the glass is scattered, an area that extends over thousands of square kilometers. It's a long, hard drive through the desert. It will take them at least 3 days before they can even start looking for any glass. Joining American physicist Mark Boslow and geologist Ali Barakat is geochemist Christian Kerbel from Vienna. Like Barakat, he's an old desert hand. They hope to find fresh evidence of the mysterious event, which must have taken place out in the desert.
We scientists have been interested in these desert glasses for a very long time. It's just such a mysterious glass. They have a color and this pure silica composition that makes them really unique in the world. We know no other natural glasses that look like this or have a composition like this. And so we scientists are still kind of puzzled how these things formed.
The puzzle for the scientists is that this desert glass is not like any other natural glass found on Earth. Most natural glass is volcanic in origin. Volcanic glass forms when hot molten magma solidifies rapidly, usually when it meets cold water. Volcanic glass is relatively common, but its chemical composition and dark color are quite unlike the desert glass. There is another way natural glass can be produced, by something even more dramatic than a volcano, an impact with an extraterrestrial body. When a large meteorite hits the Earth, the intense temperature and pressure and rapid cooling can turn the ground to glass.
There are, for example, these glasses here. They're called tektites, and they are thrown away from impact by hundreds and even thousands of kilometers from the crater. But these glasses are very different in appearance and shape and size from the desert glass that we have here.
So the glass appears not to be volcanic, nor is it like any known meteoritic glass. In fact, it's unlike anything found on Earth, and there have been quite a few theories to explain what it's doing in the desert. One theory suggests this area was once swampy, and that the glass was left behind as sediment when the swamp dried up. A key aspect of this theory is that the glass formed slowly at low temperatures. Scientists were intrigued.
When I first heard about this idea, I thought, well, it's an interesting one, that it forms at low temperature. But I wasn't quite convinced that the desert glass really formed this way.
Kerbel decided to analyze the glass to establish at what temperature it had actually formed. He turned for help to the Natural History Museum in Vienna, where one of the world's largest collections of meteorites is housed. Using their electron microscope, he searched the desert glass for a mineral called zircon. Zircon is remarkably stable, but starts to disintegrate at high temperatures. Kerbel looked for zircon crystals with light and dark patches. These patches of light and dark showed the zircon had begun to disintegrate.
And what this tells me is that the glass formed at a very short time and a high temperature. And to understand exactly which temperature we're looking at here, I need to analyze the different bits inside here.
In the dark patches, the zircon has broken down into a form of silica. The amount of zircon left in these patches shows how far the process of disintegration has gone.
In the darker areas, we have less zircon and more silica. And what this tells us is that this little zircon crystal has decomposed partly because of the high temperature, but not completely. And the ratio of the two elements tells me that the temperature was about 1,800 degrees Celsius.
1,800 degrees Celsius is hot, incredibly hot. Volcanic lava is only about 1,100 degrees Celsius. Whatever happened here in the desert, the heat required to produce the glass was phenomenal. What Kerbal found convinced him and everyone else that they had to look for another explanation. An extraterrestrial explanation.